The last topic we're going to look at in our equations unit is literal equations. And when we talk about literal equations, we're going to use basically the same steps and strategies that we've used to solve algebraic equations up to this point, except now, when we look at literal equations, they're going to have lots of different variables in them. So we're going to look at equations with multiple variables, and there will probably be fewer numbers than what we've seen before. There might be 2, 3, 4, 5 variables in a problem, and we're going to be asked to isolate just one of them. So we're still going to add and subtract things from both sides, divide both sides by numbers, multiply both sides, but now, instead of getting down to x equals 2 or a equals -5, we're going to get down to just a variable is equal to another algebraic expression. So the first equation we have here is y equals 5x minus 6, and we're asked to solve for x. This is the most important part of a literal equation because it tells you what to do. Without this, we can't really do much here. So I know that I need to get x by itself. I'm going to do the same thing that I would do to get x by itself with another equation that we've looked at, except the terms aren't going to simplify or combine as nicely as they have in the past. So first we're going to add 6 to both sides, and when I add 6, we're going to end up with y plus 6, because I can't combine those, equals 5x. So if we add 6 here, those are going to cancel out. We add 6 here. I can't combine y and 6, so those stay together. Then I still am looking to isolate x, and we are going to undo that multiplication with division. So we have isolated x, and now we have y plus 6 over 5. There aren't common factors across all three terms. I can't combine anything, so that's my final simplified answer. I've isolated the variable that they asked me to find. My fraction here is completely simplified, so there's nothing else that I can do. If we look at our next one, we're looking to solve for h. So that means I have to get h by itself. This is all multiplication, so I can undo it with division, and I can actually do this one in one step. If I divide both sides by LW, these L's will go to 1, these W's will go to 1, and we're just left with h on the right side of the equal sign. Then we have V over LW on the left-hand side, and that's as far as that can go. I can't simplify those. I can't combine anything, and that's my final answer. For these, there's not going to be any set notation or roster form. You're just going to write the expression across the equal sign from the variable that you were asked to solve for. Okay, pause the video, see if you can solve for b in our first equation here. Alright, if we look at this one, we want to get b by itself. So you have two options to start off with. You can distribute the h through, which is what we did here, or you can divide both sides by h in the beginning and work from there. The trickiest thing with these expressions is being able to recognize expressions that are equivalent. So if you divide by h in the beginning and you go through and do your work, now we have a over h equals b plus c. I want to subtract c from both sides. So we have a over h minus c equals b. And these are going to be equivalent expressions. Okay? So if this were a multiple choice question, you would need to be able to recognize that those represent the same thing. If I multiply by h over h to get a common denominator, then we would have a over h minus ch over h equals b. And that would get us back to this expression over here. The way that we did it in blue, we distributed the h through to both the terms, then subtract hc from both sides, and divide by h to get b by itself. These are all acceptable correct answers. Okay, here you would want to simplify the purple to get to the blue, but if you had this orange expression for b, that works too. So the trick with literal equations is being able to recognize when expressions are equivalent. Pause the video, see if you can find a value for y in our second equation here. The second one is a little simpler than the last one. We can multiply both sides by 2 to get our y out from the numerator, and then we just subtract x, and we get y equals 2a minus x. These are the trickier examples, because if you look, you'll notice that our variable is attached to 5 and to 2a. I can't combine 5 and 2a because they're not like terms. You could work this problem moving terms back and forth, dividing, multiplying. And you could just work your way in circles for a really long time and get really frustrated. With these types of questions, you need to remember to factor out the b. So these are questions where we're going to factor out the variable. So if I look at the right-hand side of my equation, the common factor between 5b and 2ab is b. So I'm going to take that b and factor it out. Now, in order to figure out what's left over, we divide both of these by b. When we factor something out, that's really division. And I'm going to create instead a multiplication problem. So b times what gets me back to 5b? Well, b times 5 gets me 5b. Bring down your subtraction sign. Then I say, okay, b times what gives me 2ab? Well, that's going to be 2a. So we have this, and we still have the 10 on the other side. If I want to check my work, I can use my distributive property to multiply this back through. So we would have 5b minus 2ab. And that's how we know that we factored it correctly. But we don't want to put the pieces back together. We want to keep working to see if we can get b by itself. Once I have this, I'm going to divide both sides by 5 minus 2a, because this is multiplication here. So we divide by 5 minus 2a, and that's going to end up being our final expression for b. We have b equals 10 over the quantity 5 minus 2a. Pause the video and see if you can solve for r, not y, in the second one. In our second equation here, again, we have two copies of the variable that are attached to different coefficients. Here we have a coefficient of 1, and here we have a coefficient of negative g. If I can't combine the coefficients, that's when I'm going to have to factor out my variable. So I do that, I pull out my r, I set up my parentheses, and I say, okay, r divided by r is 1, so r times 1 gets me back to r. Then gr divided by r is g, so r times negative g is negative gr. And again, we have that multiplication problem, r times the quantity 1 minus g. So I divide both sides by 1 minus g, and I get s over 1 minus g for the value of r. The SOL likes to ask questions about this just because they're good multiple choice problems. You're given the formula to find the angle measure of an isosceles triangle. We want to know which equation can be used to find x. So in order to do that, we're going to go ahead and just isolate our variable here. So we have 180 equals 2x plus y. First, we're going to start by subtracting the y. And then our last step is going to be to divide both sides by 2. So we have 180 minus y over 2 equals x. Remember that when we were simplifying expressions before, the only way I could divide was if all three numbers shared a common factor. 2 and 180 can be simplified, but 2 and negative y cannot. So my final answer has to be the 180 minus y over 2.